Today we are going to look at 11.3, which is area of regular polygons and area and circumference of circles. So regular polygons, this is 11.3 in your book, and you can find this on page 650 in your book. This is not on the Keystone formula sheet. So for any regular polygons, their area can be calculated using 1/2 p times a, which we'll talk about those variables. P is representing the perimeter of the entire regular polygon, where A is representing something called the apothem. And the apothem is a segment that is drawn from the center of the regular polygon perpendicular to the side of the polygon. And you can look at a figure in your book to kind of see what that looks like. With the regular polygons, due to the lack of time, we are only going to concentrate on using this area formula for regular or equilateral triangles. So let's do this first example here. We're going to find the area of this regular or equilateral triangle rounded to the nearest tenth. So when I look at this picture, what they're giving me, this 14, this goes from the center of the polygon to a vertice of the triangle. So this is not what we call the apothem. In this picture, this segment right here from the center down perpendicular, that's going to be my apothem. So let's start by writing out my formula. So 1/2 perimeter apothem. And so we are going to have to solve for the apothem as well as solving for the perimeter of this triangle. In a regular triangle, all the angles on the outside are 60. The way this right triangle is drawn in here, and the way they're always going to be drawn, since the whole angle is 60, half of it, the angle right here, is going to be 30 degrees, and this angle here is also going to be 60. So we're still going to be using our 30, 60, 90 rules, which I'm going to go over kind of quickly. So in this right triangle here, this one that we're concentrating on, 14, that is my hypotenuse. So my hypotenuse is 14. The short leg opposite angle 30 is going to be half of 14, which is 7. And so that's telling me that my apothem is now 7. So the short leg is 7. My long leg is the short leg times the square root of 3. So my long leg is 7 square root of 3. And that's just going to be from here to here. Okay, so we know the apothem. We know this part of my side is 7 square root of 3. That means that this part's also 7 square root of 3. And the whole side then is going to measure 14 square root of 3. So every single side is 14 square root of 3, which is going to tell me something about my perimeter. Okay, so let's look at our perimeter. So perimeter is going to be either all the sides added together, or we know all the sides are 14 square root of 3, and we have 3 of them. So I can take 14 square root of 3 times 3, which would give me that my total perimeter is 42 square root 3. And I'm just going to leave it like that for now. When we substitute in, we will make that a decimal. Okay, so now let's go ahead and substitute into my formula. So 1/2, the perimeter is 42 square root of 3, we just found. And the apothem from my picture is 7. Now we're just going to multiply that all in our calculator, round to the nearest tenth, and we get that the area is 254.6 square centimeters, 254.6 square centimeters. Okay, we will do another regular triangle at the end after we look at circles here. So area and circumference of circles, this is on your Keystone formula sheet. So circumference is the entire distance around the outside of the circle that is used instead of perimeter. Since we're looking at a circle, that's 2 pi times r, so that's this first formula. And then area is pi r squared, and r, of course, is representing the radius of the circle. And the radius of a circle starts at the center and extends to the other side, as you can see on the picture. Okay, so let's look at this first picture. So we're going to find the circumference and the area of this circle that is given. On this picture, 12 is my radius. Let's start here on the left with circumference. So circumference is 2 pi r. So circumference is 2 times pi, and then my radius is 12. An exact answer for this would be to take the 12 times 2, which is 24, and leave it in terms of pi. So 24 pi would be your exact answer here. We are going to round to the nearest tenth, so you can type that in, and you can just use the pi symbol on your calculator. Don't use 3.14. That way we get a more exact answer. So 24 times pi is 75.4 feet. And circumference, since that's like perimeter, is just measured in feet. Okay, now let's look at area. So area is pi r squared. So that's going to be pi. The radius again is 12. So pi 12 squared. Exact answer would be to take 12 squared, get 144 pi. Okay, we don't need an exact answer, but that's what the exact answer would be. Let's round it to the nearest tenth. That would give me that the area is 452.4 square feet. And that would be the area of this circle. Okay, let's keep going. This one, we're just going to find the area of the semicircle, which is half of the circle. So in this case, the shaded part. On this picture, since 8 is kind of in the middle here, that means my diameter, the whole way across my circle, is 8. And so the radius would be half of that. The radius would only be 4 meters. And we're going to find the area of the semicircle, or half. So area of a circle is pi r squared. But we don't want the whole circle. We only want half. So we're going to take that pi r squared, and we're going to divide it by 2 or multiply it by 1/2. Now let's substitute in pi, the radius we said was 4 squared, divided by 2. An exact answer would be 4 squared, which is 16. 16 divided by 2 is 8 pi. That would be the exact answer. Rounded would be 25.1 square meters. 25.1 square meters for the area. Okay, let's look at some problems working backwards. So given what we know about an area and finding the radius. So for example, area of a circle is 58 square inches, and we want to find the radius. So area pi r squared. So the area is 58 pi r squared, and we want to find the radius. So first what we're going to have to do is divide by pi, and I would say go ahead and do this on your calculator, and let's keep 2 decimal places or round to the nearest hundredth. 58 divided by pi is 18.46 equals r squared. Okay, then to get rid of the squared part, we're going to take the square root of both sides. And so the radius, square root, now we'll round to the nearest tenth, is going to be 4.3 inches. And it's always a good idea to double check your answer. Try maybe plugging in 4.3 and just validating that you get something that would be close to 58, since we are rounding. Okay? Let's do another. So we're going to find the area of the circle given the circumference. So this time they're giving me the circumference. From the circumference, we're going to find the radius, and then we're going to use that to find our area. So circumference is 2 pi r. So I know the circumference is 48 pi. And I need to solve for r. So I'm going to divide both sides by 2 pi right away. And I can do that together. The pi's simplify out on both sides. So then I just end up with 48 divided by 2. which is 24. So now I know that my radius is 24 meters. From that radius, I'm now going to find the area. So area is pi r squared. So that's pi 24 squared. An exact answer would be 576 pi square meters, and rounded to the nearest tenth would be 1,809.6 square meters for the area. Okay, let's finish up with one last example. So this one's a little different. It's going to incorporate this regular triangle idea and a circle. So we're going to find the area of the shaded region. The triangle, that shouldn't say inscribed. The triangle that's on the outer part here is an equilateral triangle or a regular triangle. Okay, and we're going to round our final answer and as we work to the nearest tenth. So in order to find the shaded area, we're going to have to find the area of the bigger shape, which in this case is the equilateral triangle. So the area of that minus the area of the circle on the inside. That's going to give me just the shaded part. So let's start by finding the area of the triangle. So this is an equilateral triangle, so we're going to use that 1/2 perimeter apothem again. If I look at this picture, the way this 4 is drawn in the triangle, it's going from the center to the side, and that is perpendicular. So that 4 is serving as my apothem. So I'm just going to finish this right triangle here. Okay, so that would be kind of like my right triangle, keeping in mind that this angle, let me redraw it. So that would be my 4. This angle is 30, and this angle is 60. We need this side, my longer leg, in order to find the perimeter. So if the short leg is 4, the longer leg is 4 square root of 3. And so the entire side would be 8 square root of 3. 4 square root of 3 plus 4 square root of 3, 8 square root of 3. And so then the perimeter is going to be 3 for 3 sides times that 8 square root of 3, and that'll be 24 square root of 3. Okay, so now let's go ahead and substitute in. So 1/2 perimeter we just said was 24 square root of 3, and the apothem we said was 4. Can just do that in our calculator. I'm just going to round it to the nearest tenth, and 83.1 square feet would be the perimeter of, or I'm sorry, not perimeter, area of just the bigger triangle. So now let's do the area of my circle, and then we're going to subtract them. So area of a circle is pi r squared. So that's going to be pi. In this case, this 4 is also representing the radius of the circle. It's starting at the center and it's extending to the edge of the circle. So pi 4 squared, which would be the same as 16 pi, rounded to the nearest tenth, is 50.3 square feet. Okay, and so now, now we're going to subtract those. So 83.1 minus 50.3 gets me an area of 32.8 square feet. 32.8 square feet for the shaded area of this shape.